Why do PC games stutter during shader compilation? Imagine you're in the middle of an intense game, and suddenly the action slows down, causing pauses or jumps in your gameplay. You might wonder what's going on behind the scenes. Well, one common reason is shader compilation. Shaders are tiny programs that tell your graphics card how to draw objects, handle lighting, shadows, textures, and special effects. When a game encounters a new scene or effect for the first time, it needs to convert these shader codes into a format your graphics card can understand. This process is called shader compilation. It's done by your computer's central processing unit, or CPU, and it can take a little time depending on how complex the shader is and how fast your CPU is. When the game is doing this shader work during gameplay, it causes a spike in CPU workload. That spike can temporarily slow down the game because your system is busy converting shaders instead of rendering frames smoothly. This is especially noticeable when you move into new areas or see new effects because the game has to compile multiple shaders quickly to display everything correctly. Once the shaders are compiled and stored in the cache, the game doesn't need to recompile them every time you revisit the same scene, which helps keep gameplay smooth. Several things can make shader compilation stutter worse. If your CPU is already busy with other tasks or the game itself, it can't keep up with shader compilation, leading to more frame drops. Modern games use many shaders to create detailed visuals, which means longer compilation times and more frequent recompilations if the cache is small. Some games don't precompile shaders before you start playing, so they compile on the fly during gameplay, which can cause pauses. Also, if your shader cache is too small or not optimized, the game might need to recompile shaders more often, causing repeated stutters. To fix or reduce this problem, many games now let you precompile all shaders before playing. This process can take several minutes to half an hour, but it means fewer pauses later. Some games also compile shaders in the background or during loading screens, so your gameplay isn't interrupted. Increasing your shader cache size in your graphics driver settings can help store more compiled shaders, reducing recompile times. Limiting your frame rate can also help your CPU focus on shader compilation without overloading. Lowering graphics settings like draw distance or particle effects can reduce CPU and GPU load, making shader compilation less noticeable. From a performance and troubleshooting point of view, shader compilation stutter is a common cause of frame drops and uneven gameplay. It's often mistaken for other issues, but it's really about how shaders are handled during runtime. Managing this involves both game updates, like pre-compilation options, and user adjustments, such as cache settings and frame rate caps. In short, when you see your game stutter during play, it's often because your CPU is busy converting shader code into instructions your graphics card can use. This process takes time and can cause temporary delays. Keeping your shaders precompiled and optimizing your system can make your gaming experience much smoother.